How's it going, guys? My name's Josh, and in this episode, we'll be implementing some basic character movement. In the last video, we imported our content and created a character blueprint so that everything would be ready to begin implementing our character movement script in this episode. So if you haven't already seen the other parts of this series, I'd recommend you go and check those out first. You can find the link to the playlist in the description, or it should appear on screen somewhere around here. Or else, if you support me on Patreon, you'll gain access to all of the files from all of my tutorials and projects, which are yours to learn from or modify. Alright, Patreon plug out the way, let's see what's on the agenda. We're going to set up some key bindings, add events for movement input, and update our animations to match our movement using functions and enumerators. It's pretty simple stuff, and we'll be making use of built-in movement functions to make it even easier for us so that we can get on to learning the rest of the process. Let's get started. So let's just start by going ahead and opening up the project from last episode. Once that opens up, the first thing we want to do is set up our key bindings. To do this, we need to go into our project settings, which you can find under Settings, Project Settings, or Edit Project Settings. Then go and find the Input tab. So the first thing you want to do is add a new axis mapping by clicking the plus icon. We'll name this axis mapping Move Right. I'm setting both D and the right arrow key to +1 for moving right, and A and the left arrow key to -1 for moving left. Next, you can add an action mapping. Name that jump and select which keys you'd like to use. Now we need one more action mapping that will be used for both running and attacking. Now that we've got the bindings set up, close the project settings and go and find our player blueprint. Make sure you select Open Full Blueprint Editor so that we can head over to the event graph. So just delete everything out of the event graph, and we want to add the event that's linked to our axis mapping that we just created. To do this, right-click in the event graph and search for the name of the axis mapping, which will be Move Right. There should now be two options to choose from, one under Axis Events and one under Axis Values. We want to choose the one under Axis Events. And what we want to do with this is take the execution output, drag off, and search for Add Movement Input. This is a built-in movement function that is part of the character movement component, which will handle more complex things like collision interactions for us, which is great. So set the world direction to be 1 on the x-axis, and then take the axis value and plug that into scale value. What happens here is the world direction is multiplied by the scale value, and since the scale value is set to our axis value, whenever our axis value is 0, in other words, when we're not pressing A or D, the world direction will be 0 and the character won't move. If we hold D, the axis value will be equal to 1 and our character will move to the right, and if we hold A, our axis value will be -1, so the world direction will be -1 and we'll move left. So, to test that this is working, let's open up the level that we created last time. Just scale up that placeholder cube along the x-axis so we have a bit of room to move. Now when you hit play, if you have the window selected, you can now move the character left and right with the arrow keys or A and D keys. Now what we need to do is make sure that the sprite flips around when we change direction. So drag off of here and add a compare float node. Then take the axis value, and I'm rerouting it around the movement input just to keep things tidy, and then make sure that you plug that into the input of the compare float node. So once you've got this, you've got the input is greater than 0. If that's the case, this means we're holding D, so we have a value of 1, which is greater than 0, and we'll be moving right. So we want to make sure that our character is facing right. So we want to set the relative rotation of the sprite to be 0. That's default. So he's already facing to the right. And then you want, if it's less than 0, which will mean that the player is moving to the left because we have an axis value of -1, you want to set the relative rotation of the sprite to be 180 on the z-axis. So this will flip him completely around. So if we test this now, there you go, he spins around and is now clearly turning whenever you change directions. However, he's still in his idle pose, which is not what we want. We want him to change to his running animation whenever he's not idle. So the easiest way to do this would be to just drag off and set flip book, and then choose the flip book, and it would be run. Just do that and then that, so that whenever the player is moving left or right, it changes animation to run. They see, but it then gets stuck there. So all you do is add another one and chuck it as equal to, connect it to the sprite, and set it back to idle. And then there you go, you've got your run animation, and it's quickly turning quite nice for us. One thing I'm going to do real quick is find our camera in our scene, go to camera actor, and just set the ortho width to be wider than it currently is, so we aren't so zoomed in. So you can see it's kind of what we're going for. The only issue there is that when you start to add more animations doing it like this, it becomes quite tricky to keep track of what animation should be playing and all the conditions that you need to make sure that you're switching to the right animation at the right time with no errors. So we're just going to get rid of that entirely and just save it. And what we're going to do is we're going to go back into our content browser, and we'll make a new folder for this. In fact, we'll call this, we'll make a blueprints folder, add our character in there, and then add a new folder. I'll call this utility. You don't have to do this. This is just how I like to organize things. You organize it however you like. We want to look for, under blueprints, we want enumeration. So we want to call this enum underscore anim state. So open that up and add an enumerator. We'll call this idle and then give it a description. Add enumerators for both running and jumping, and we'll leave it at that for now. And then what you can do is, if you go into your blueprint, you can create a new variable, and if you click here on this little icon, you can change the variable type, and we want to find enum, and look for enum anim state, and compile and save that just so that you can change here. Just press F2 to rename it, and we'll call this anim state. Compile again, and you want to change the default value, you can. We want to leave it at idle for now. And so now what we can do is we can use this variable here to set the anim state much easier, rather than changing the flipbook from multiple different locations, we can instead just set this anim state variable and then do all of the flipbook changing in one location, which would be much easier to keep track of and make it much more readable and understandable and easier to debug. So we can do is connect these up now to the anim state and set that to be run. Set this one to be just set anim state, and this time set this to idle. So you compile that and save it. And then what we need to do now is we want to create a new function, and we'll call this function update animations. So inside of our function, what we want to do is just drag off and want to do set flipbook sprite, and we've got here our flipbook being set, and where it says new flipbook, you can choose the flipbook from in here, but what we want to do is we drag off here and grab a select node. You can take this here, I'll move this out the way a bit. We can grab our anim state variable and just drag it in and get it. We can use this as our index, and then we can choose basically if we're in the idle state, which animation we'll use, if we're in the run state, which animation we'll use, and if we're in the jump state, which animation we'll use. And if you save that and close out that, we need to call our function now, and we want to be checking this quite frequently. In fact, we want to check this, we're going to be updating the animations every frame in case the state changes on any given frame. So what you can do is just add an event tick node, and this is an event that is called every frame, and drag off that and just add your update animations function. So if you compile that and save that again, now you can test one more time, and look, it does the same thing it was doing before, except far cleaner now, far easier to understand. And there you go. So we'll just add our jump action event that we created, chuck it in here, and on pressed, we just search for a node called jump. We once again have a built-in character movement function for jumping, and we have one also for stop jumping. Now just save that and test it again using your jump key. Well, look at that. So if you go into this update animations, you can just drag these to the side a bit so you got a bit more space to work with. What you want to do is right click to add a node and search for is falling, and basically this boolean will be true whenever the character is in the air. So if we drag off and add a branch and connect that up here, what we can do is set anim state to jump when this is true, and then just reroute this around here, keep things clean. And hook that back up. Now if we compile and save that and test it, we do have our jump animation whenever we're in the air, so that's perfect. And so we've already got a really good start, and the only thing left to do now in this episode is we want to be able to sprint, right? We want to have two different speeds, so we'll add in our shoot/run. Gotta grab the character movement node and max walk speed, set it to, let's say, add another one for released, right? And set that to 1200, set that to 100 just so you can see the difference. And you want to set the default max walk speed in the character movement component to 100 as well. So that's your run speed and that's your walk speed. There's a big difference, but one thing you'll notice is that regardless of the speed that the character's moving at, the walk animation stays at the same rate. So that's a bit off-putting. It looks like he's running at the same speed even though he's moving a lot slower. So what we want to do to fix that is you just grab a sprite and play rate, set play rate. We'll chuck this in the middle here, grab two of these and connect them up, and you want the play rate to be, let's go with 1 for default and 0.6 for when you're walking. So there you go, he's walking a bit slower, now he's running, and that should be good. So what you can do is, if you just select all of that in the graph and you just hit C, you get a comment node, and we'll call this movement. Then you can come up into the details panel, change the comment color. We'll go with something like that, and I like to color the bubble as well. Just chuck it up here, resize it. It's my OCD getting the better of me there, and this can be, we'll just call this tick, and we'll make this, I don't know, okay, green. Green seems to make sense to me, I guess. And with that done, we can just call it a day, I think. Anyway guys, I hope you enjoyed. If you did, leave a like and consider subscribing for more game design related content available each week. Don't forget to check out my Patreon if you like what I do and you want to show your support. You can see the benefits if you check out my page down in the description. If you have any questions, then make sure you leave a comment, or if you feel like sharing your work, you can tag me using one of the social links in the description. Other than that, have a good day and God bless.